Hello, good morning everybody. So this is uh, additive manufacturing, third module, powder metallurgy. So this powder metallurgy chapter I am discussing in continuation with my regular classes that I have taken. Since now we are having the lockdown, so I will continue with the leftover topics of this powder metallurgy chapter. So we are left over with some topics. So here we are supposed to discuss characterization techniques. So just briefly let me tell what is powder metallurgy. So powder metallurgy is a metal processing technology in which parts are produced from metallic powders. So these powder metallurgy parts need to be analyzed to determine some of the few things like chemical composition and structures. So we can characterization techniques helps us to determine the chemical composition and its structure. It also helps us to determine particle size and shape. So even by using scanning electron microscope SEM, so we can study the friction between the particles, how the relation is existing between the two particles, their flow characteristics, how the powders are binded or compressibility of powders, their shape, particle shape. As we know that particle shape may powder shaping. Why it is important for us to have a proper shape of the powder? So we require a proper shape of the powder for few reasons, like for good compaction. For a good compaction, we require usually irregular shaped particles. Why irregular shaped particles are preferred in powder metallurgy? Because these particles will bind properly, or they interlock properly and try to improve the grain strength of the component. So for good compaction, so we also require powders which have apparent density. Okay, so the apparent density of the powders will decide the die filling during the compactions. Hence we require powder size, which is very important, the shape and density, and the apparent density. So flow rate, so the flow rate of the particle also affects the powder metallurgy component. So flow rate affects the die filling time. So if the flow rate is less, then the die takes larger time to fill. So flow rate affects the die fill time, and once again powder size, shape and density affect the flow rate. So that's why we should concentrate more on the shape of the powders. So the next topic is lubricants and binders. So as we know that the powders used in powder metallurgy, preparation of powder metallurgy component are mixed. Two or three two metallic powders are mixed. So to these powders we add some lubricants. Why these lubricants are added? So these lubricants are added in order to improve the binding property between the two particles, and these lubricants try to reduce the friction between the die wall and the powder particles. So the usually organic compounds such as waxes and metallic steroids or salts are generally used as lubricants for preparing powder metallurgy component. The amount of lubricant added should be within 0.5 to 2% by weight of the charge. So charge here is nothing but the mixture of the powder taken. So 0.5 to 2% by weight of the charge we should add the lubricant. So lubricants can be added by two methods. One is mixed lubrication, the other one is die wall lubrication. So in mixed lubrication, so the lubricant is mixed along with the metallic powders. So here this type of lubrication will try to reduce the interparticle friction and helps for better packing. So better packing in the sense the voids between the particles will be reduced. So that's what it does. So if we go for mixed lubrication purpose, so this type of lubricants, when they are added to the powder metallurgy component, they affect the densification property depending on the volume and density. That is, they affect the density of densification property. So therefore these mixed lubricants, once they are used, they should be removed before sintering to avoid distortion of compact. So as we know, sintering is a process which is carried out after compacting. So these mixed lubricants should be removed before sintering to avoid distortion of compact. The second method of using lubrication is die wall lubrication. So die wall lubrication is the one wherein the lubricant will be applied physically on the die and the punch surfaces. So they can be easily removed. So this method of apply using the lubrication will take longer production time. So this is the drawback of this die wall lubrication. So what type of lubricants are used, or which are the commonly used lubricants? So usually paraffin wax, aluminum stearate, lithium stearate, zinc stearate, magnesium stearate and stearic acid are the commonly used lubricants for preparing powder metallurgy component. Along with lubricants, we also had some type of binders. So what are these binders? So binders, what is their purpose? So binders are used to increase the green strength of the powder compact. They try to increase the green strength. They are also used for reducing, or the binders are used to promote the interfacial bonding. So the interfacial bonding between two particles is improved by adding these binders. So the commonly used binders are wax or thermoplastic polymers. Isostatic pressing. So isostatic pressing is one of the compaction method for compacting the powder metallurgy component. So once the powders are mixed, they need to undergo pressing. So here isostatic pressing is a powder metallurgy forming process that applies equal pressure in all directions on a powder compact. So isostatic, as the name itself says, the pressure applied on the powder metallurgy component will be unique or equal in all the directions. So the main advantage of this isostatic pressing is that this achieves maximum density and microstructure without geometrical limitations of uniaxial pressing. So what happens in case of uniaxial pressing? As we know, in case of uniaxial pressing, we have only a die and a punch. The pressure will be applied only in one direction, wherein it will pose to some limitations. That means the compacted green powder metallurgy component will have lesser density at the bottom, and the density of the powder compacted will be more at the top. So this disadvantage can be overcome by using isostatic pressing. So isostatic pressing helps us to achieve maximum density and microstructure. Isostatic pressing can be carried out by two methods. One is called as cold isostatic pressing. The other one is called as hot isostatic pressing. So cold isostatic pressing is the one wherein it is used to compact green parts at ambient temperatures. So cold isostatic pressing is used to compact green parts at ambient temperatures, whereas hot isostatic pressing is used to fully consolidated parts. It is used to fully consolidate the parts at elevated temperatures by solid state diffusion. It can be used, hot isostatic pressing can also be used to eliminate residual porosity. Any porosities that are left during compaction process can also be reduced by using hot isostatic pressing. So isostatic pressing helps us to achieve maximum density. So you can carry out it by using either cold isostatic pressing or hot isostatic pressing. Injection molding. So injection molding is one of the process of which is also called as powder injection molding, PIM, powder injection molding. So powder injection molding is a process, okay, wherein it is an efficient method for high volume production of shaped components from powders. So we can produce products, okay, in large volumes by using this method, that is powder injection molding method. So this is a derivative of polymer injection molding. So the same technology is adopted for preparing powder metallurgy parts also. So in this method, the mixture is heated in a screw fed barrel. So as you can see in the figure, okay, the powder and binders and additives are mixed here. So this mixture is heated in a screw fed barrel and it is forced under pressure. So this mixture, okay, the mixture of all these powder, binder and additives is forced under pressure into a die. This is a setup, okay, wherein it consists of a die. The powder, mixture of the powder is forced into a die or into a die cavity. After pressing, the process of injection molding takes place here. So it is taken out, the product is taken out, debinding takes place, then it is sent for sintering process, and then the final product is obtained. So powder injection molding carries out these basic steps. That is, the powder, binder and additives are mixed and it is forced through a die, or then this is wherein we call it as an injection molding process. So once the powders are injected through the die on one side, you get the component. So the component is sent for sintering and the final product is ready. So this is called as powder injection molding. Powder extrusion. Even the powders used in powder metallurgy technique can also be compacted by other method called as extrusion method. So in case of powder extrusion, the pressure is applied uniformly on the powders used. So powder extrusion can be carried out by two methods. One is called as cold extrusion and the other one is hot extrusion. So in case of powder extrusion, we apply hydrostatic compressive stresses and shear forces. So hydrostatic compressive forces and shear forces are acting on the powder. So here the powder is having high density. The compacted powder will be having high density. So in case of cold extrusion, of powders, what we do, it requires only a very less amount of binder. Cold extrusion process requires less amount of binder, that is up to 50% of binders are required. So some of the binders such as paraffin waxes, starches, benzol, resin, shellac are used. So these binders that are added during cold extrusion process, they have to be removed during sintering. Okay, so this is in case of cold extrusion. Whereas in hot extrusion, the hot extrusion of powders is usually carried out by canning process. So the process of hot extrusion uses what? A canning process wherein the powders are evacuated and sealed at the end. So that is hot extrusion. Slip casting. So slip casting is a well-known fact that conventional metallurgy, powder metallurgy, in powder metallurgy process we use. So here pressure compacting of metal powders and subsequent sintering. So that means what? Both applying the pressure, compacting and sintering of the compact are taking place in several steps. So all these are happening in one step in case of slip casting. So figure below shows a slip casting process wherein it makes use of a mold. The first figure A shows a plaster of Paris mold. So we require a plaster of Paris mold. Into this plaster of Paris mold, the inner surface of the mold is applied with some release agent so that the part can be removed easily. Next, we require proper preparation of a slip. Slip is nothing but the mixture of the slurry that we pour into this POP mold. This slip consists of various powders, deflocculant, water. So all these things are mixed in proper ratio and allowed to mix, and then it is poured into this plaster of Paris mold and it is allowed to set for 10 to 20 hours. The slip, once it is poured into this mold, so in the figure B you can see that the slip is being poured into the plaster of Paris mold. Once the slip is poured, it is allowed to set for 10 to 20 hours so that the moisture present in the slip is absorbed or it is dried. And after pouring, we can see that in figure C the mold is left for setting, and figure D indicates the final product obtained after removing the or detaching the part from the POP mold. So if there are any extra flash materials are available, so they are just trimmed away and the final product will be obtained as shown in figure D. So sintering, as I often say that this is one of the basic, very important step in a powder metallurgy process. So sintering is a process wherein once the compacted powder is obtained, it is sent for sintering, wherein we try to improve the strength or the hardness of that compacted powder. So sintering is nothing but heating of the green compact in an oven. So the compacted powder, which is called as green compact, is heated in an oven. So sintering can be taken place by two methods. One is solid state sintering, like next one liquid phase sintering. So solid state sintering, in this type of sintering, in solid state sintering, the powder does not melt. The powders that are mixed for preparing the powder metallurgy part do not melt. The powder does not melt, but they join. The powders get joined. So once they are placed in the oven at certain temperature, instead the joining of the particles will take place and the porosity will be reduced in solid state sintering. So solid state sintering is a process wherein the compacted powder will be placed in an oven. So this will try to bring the particles very closer, reduces the porosity also. Liquid phase sintering. So the second one. So liquid phase sintering is a process for forming high performance multi-phase components. So liquid phase sintering is used, okay, for forming high performance multi-phase components from powders. It involves sintering under conditions where solid grains coexist with a wetting liquid. So liquid phase sintering, the solid grains will be coexisting with the wetting liquids. Liquid phase sintering method is getting more and more common nowadays. So this is liquid phase sintering. So the few of the applications where powder metallurgy finds are listed below. So powder metallurgy, as we know that the material wastage will be less, so therefore, and the following are some of the applications where powder metallurgy is used. So it is mainly used for the preparation of filters. Since we know that powder metallurgy components are porous in nature, so they are used for preparation of filters. Powder metallurgy also finds wide applications for making cutting tools and dies. Even some of the machinery parts are also prepared by powder metallurgy techniques. It is used in making machinery parts. So these powder metallurgy parts are widely used in making self-lubricating bearings. They are used for preparing self-lubricating bearings. So usually, since they have the self-lubricating property, they are used for making bearings and bushes. They are also used for making magnets, and ceramic parts such as spark plugs and insulators are made by powder metallurgy technique. Thank you.